The T3 Crew Planning and Scheduling module covers these applications and functionality. Let's start with the Crew Demand Planner, where we can create different crew requirement plans with full flexibility. You might need a driver or a driver with a guard, or a driver with a guard and cabin staff. You can define the number of resources required along with the competence profile. These crew plans are assigned to the transport service that you operate, and this could be either train, flight, or a ferry service. These services need to be set up here, along with the establishment rules and other details. This service is a train. We can see the train number defined as a service ID, and the service name along with the fleet or asset used. You need to define the organisation or division, operating unit, and the hub where this train operates from. You also define the operating pattern of this service, and then assign a crew plan or CRP so that the system can identify crew demand or the requirement to operate this service. The shift-wise running schedule or trip level information can also be defined if needed. This helps the system to forecast long-term crew demand. However, short-term demand is generated from the train timetable. So let's see how this gets uploaded in the system using a file transfer or by uploading a data template for the given time period. This includes service information and train trips planned on each day, along with the routes they are scheduled for. The system converts this timetable into the crew demand and subsequently schedules crew against the demand robotically. Let's move to the RPA, where all the rules and preferences are defined. This RPA is set up for the train crew. Along with the operating unit and the depot going to use this RPA is defined. The input criteria used in this case for demand generation is the train timetable. And more details, such as prior reporting, handover time, etc., is defined along with the duty limit. Let's move along to the next step where scheduling preferences are defined. You can define multiple rounds and methods for scheduling. This is done to ensure maximum coverage in the first round. In this case, the system will schedule crew based on the competence requirements, and then schedule standby staff to cover the gaps if any, and finally use statistical data to cover any remaining gaps. Let's move to the next tab, where we define shifts that need to be covered. Along with the positions that need to be included in this RPA. Let's move to the crew allocation and gap monitoring app to identify if there's any gaps in the crew schedule or tasks generated by the system robotically. We define the period and select the operating unit along with desired work location or depot shift. The system will display consolidated services and trip view for the selected location and period, populating services and trips in the selected depot, along with the duration and destination details. The green dot indicates no gap in the coverage, while the red dot indicates a problem or gap in the scheduling. Here's a case showing a red dot. So let's have a look, and yes, there seems to be cabin staff missing, but you can easily find standby staff available, along with the competence profile and availability. Now moving to the Day of Operation app to identify if there's any risk element in the schedule, while defining all the parameters needed to populate required records. Here we're trying to populate data for the given operating unit, depot, and the day, which is the 17th of August in this case, while leaving the shift empty. This will populate a consolidated shift view of the services. The data is now populated as per the given criteria, and we notice a red dot in one place. When we drill down into the trips, we can easily view that for trip number 2184, there is a gap, and when we click on the Detail button, we come to know that cabin staff are missing, and the reason is the shortage of competent resources available in the depot or location. There are several other applications in this module, including current demand and supply, allocation efficiency analysis, and multiple data analytics for the workforce planners to efficiently manage crew operation with minimal manual activities. That concludes this scenario. Thanks for watching.